really welcome each and every one of you to bring your voice. When we get into the chat thread portion with the group conversation, if you don't feel bold enough to raise your hand and bring your voice to the plate, type in your comments. Please keep your comments to 2 minutes. Please stay on topic. That's really hard because everything relates to everything. Scott will tell you that. So I'm going to turn it over to Tim here with, I hope you have your pen and paper. And Tim has put a lot of work into this every month. We don't even send him a paycheck. He's a volunteer, man, but he's putting together wonderful material, lesson plans, PowerPoints. And Tim, take us to the promised land, bro.
All right. So first of all, thank you for everyone for coming and giving us your time and attention, and I hope that you see value out of this. We're really doing this so that we can all live and breathe and eat and sleep the message. And this is just a way to have a conversation. So thank you so much. So today we want to talk about the 9-octave periodic table in lightweight format. So we're going to cover a lot of the same things that we've talked about over the last several months. And the reason is because we started with a light unit and we're still on light units. And for as long as we're going to be doing this, we'll be on light units. You are a light unit. The solar system is a light unit. The universe is a light unit. All motion in the universe happens inside light units. So with that, the one substance that the universe uses for all of its creation is mind, which is so difficult to get your mind around. We call it a light unit. We also call it mind. And we also say that mind is a substance, a material substance. And this is the foundation of the universe. So today we're going to talk about how light units gang up and form the periodic table in lightweight format. But before we do that, let's have a little bit of history. The first periodic table that we're going to talk about was developed by a gentleman called Mendeleev, Dmitri Mendeleev. And I can't remember the year. I think it was 1857, but don't quote me on that one. Interestingly enough, Mr. Mendeleev, as the story goes, was working with index cards, our modern day equivalent of what he had. And he had, each one would have the an element for the periodic table on it. And he was trying to figure out how to arrange these so that they would make sense. And he was working late into the night. He subsequently fell asleep, and when he woke up, he dealt out the index cards in the shape of the periodic table and claims he was divinely inspired to do so. So that is the story of how he actually put these index cards in this configuration. It's important for us to understand that as we proceed through time, we stand on the shoulders of these great scientists. We still use this periodic table today, and it has served mankind up to this point. Keep in mind that we are heavy on sensed observation and light on knowledge for now, but this at least got us to this point. In 1926, with the printing of the Universal One, Dr. Russell showed the world the 10-octave periodic table in lightweight format. At the time, he was still putting this together, and it was his recollection that it was 10 octaves. Lau, in conversations one night, made the comment that our number is 9, and she believed the periodic table is a 9-octave table, not 10. Later, during atomic suicide in 1957, Dr. Russell corrected his first attempt and changed it into a 9-octave periodic table, which is what we use today. The world still uses, the scientific community still uses the Mendeleev table. But if you use the periodic table in lightweight format, I think you'll quickly find that it is far superior for several different reasons. Before we go forward into the table, let's take a step backwards and let's talk about the forces behind the table. What makes the table work? And that is gravitation and radiation, which is the one force in the universe. And it can be complexed into 18 different dimensions. Gravitation and radiation form a trinity. And just to refresh your mind, a trinity is opposite conditions centered by the one. So whatever the subject is, humans, it'd be man, woman. In this case, when you're talking about the basic fundamental forces in the universe, it's gravitation and radiation. Gravitation is compression. Radiation is a release from compression. And these are the two forces. Gravitation is a generative force. It's trying to assemble the entire universe into one solid clump. Radiation is the power of magnetism to disassociate by replacement. Radiation is trying to radiate the universe to the far corners. And those are the two powers that are in constant opposition with each other in order to form the periodic table. And with that, let's take a look and see what makes up an octave. Here's a diagram I put together that shows the periodic table, and it combines a few things like the color spectrum so that we can begin to incorporate that into our usage of the periodic table. Dr. Russell didn't have graphic programs to help him do this. So this is something that I've been able to put a little bit of time into and develop in order to try to understand this to a finer degree and have more of the qualities of and the dimensions of the periodic table available to me at one time. So an octave consists of the fulcrum, which in this case is the inert gas, and then two levers. And we have a trough and a crest. And you can see in the first diagram there that there is a inert gas that anchors this octave. That would be alpha non, and that's where we're going to start this study today. It goes in two directions. This universe is a bidirectional universe. One arm goes up to tomium, which happens to be the last element in the periodic table, and we're going to cover that in some detail tonight. And it extends in the other direction to Athenon, which is the first example of wave amplitude after tomium, after alphanon, which carries a designation of 100. The inert gases all end in 00. So it's 100, 200, 300, 400, all the way up to 900. The elements are all numbered either 101 plus, 102 plus, 103 plus, 104 plus plus, which signifies the meeting of two waves at wave amplitude centered by God, the secondary vertical inertial plane. And then it will proceed in the downward direction, 103 minus, 102 minus, 101 minus, and then it will hit the inert gas, 200 Betnon. So that's how an octave works. And you can see that the periodic table is broken into an octave here with two waves centered by a fulcrum. But you can also see that we're going to discuss an octave, particularly when we hit the 5th through 9th octaves, by discussing it as two waves coming together with wave amplitude in the middle. And that gives us a chance to look at the octave that is created by the two waves coming together. In the first octave, gravitation completely has the upper hand. Remember, in a trinity, gravitation and radiation are the two parts of the trinity centered by the one. No part can ever have a numeric value of 0. Both parts must always have a positive value. So one part could be 99%, the other part could be 1%. And it could actually be 0.0001, and then the other side making up the difference, just to give you an idea of the granularity of the data that's present. So in this instance, gravitation is somewhere in the high 90s as far as its hold on matter. It's approximating clumping up matter to a very high degree. These are very small elements coming off of Alphanon. These are very small little solar systems. And I want to remind you that our solar system is either iron or manganese. So these are also solar systems. They may be smaller and less complex, but they work the same way. So the first 3 octaves we're going to handle right here because we know really very little about them. And the most important thing for right now is to know that there are 21 elements and 3 inert gases before achieving hydrogen at wave amplitude in the 3rd octave. And these are very poorly understood. As a matter of fact, it's only in the last 50, 60 years that we're beginning to sense down to these levels. So this is new to us. And Dr. Russell, as the visionary that he was, pointed all this out. Okay, so we kind of are glancing through this stuff because there's so much here that 25 minutes doesn't give us a chance to go into much detail. So we're going to talk about the highlights here. And one of the main highlights is the 4th octave. The 4th octave features carbon at the very center. Carbon, as you know, is the balancing point of the periodic table. This is the very center of the table. If you look at the table as a whole, it seems to be very much on the smaller side. But if you look at it mathematically, it's in the very center. So it may not balance with mass or volume, but it does balance overall. So when we hit carbon, the 4th octave, this is our octave. This is the octave that we really live in. We are composed of carbon, and when we look at the 4th octave in terms of a diagram that Dr. Russell put out in Atomic Suicide, he shows us clearly that between the 3rd and the 5th octave, going from hydrogen on the 3rd octave to silicon in the 5th octave, and forming a triangle with oxygen in the 4th octave, this is the area where life flourishes. These are the elements that we need to exist. And this is a good example of why this is considered our octave, the octave that we live in. If you get past the 5th octave in silicon, you'll find that it becomes quite inhospitable to the human condition. So from hydrogen through carbon all the way to silicon, life finds most of its complementary elements here. And silicon is carbon 1 octave removed, as hydrogen is carbon 1 octave before. And this is a good opportunity to think about mind as the one substance, and it can take on 3 different forms at wave amplitude in 3 different octaves to do 3 entirely different things, all of which are necessary for us to live. Everything's necessary, but this highlights this to a degree which is more apparent than some of the other octaves. So when we look at the 6th octave, something really amazing happens here. Ever since carbon, radiation has taken the upper hand from gravitation and started to have its way with the elements. It is now preponderant, meaning it has more than 50% of the influence in these elements now. The octaves are all starting to get bigger. And by the way, they're getting bigger by a multiple of 1.618, which is the golden means. So every time that we cross the inertial plane and then start the next wave is bigger by 1.618, and that is no coincidence. So in the 6th octave, we begin to see a particularly special effect that comes into being with radiation getting the upper hand in this battle with gravitation for control of the elements. When you hit the 603 plus position, 5 additional locking sites open up between the 3rd and 4th or wave amplitude positions. And these allow in nature for naturally occurring isotopes. This is the first place they have occurred. And one of the things that I want to bring to your attention is that there are 2 elements called bbgen and ethlogen that are in the hydrogen octave. And when Yale University followed Dr. Russell's instructions and isolated and found these elements, they renamed them deuterium and tritium. They still placed them in the hydrogen octave, but they called them isotopes of hydrogen, which Dr. Russell immediately pointed out is an impossibility in the 3rd octave. You do not hit isotopes until you hit the 6th octaves, and therefore tritium and deuterium are full-blown elements. So that's not only a good reminder that Dr. Russell contributed those 2 elements, along with 2 others that we'll discuss in a bit, to the periodic table, but also correctly positioned them. And right now, they are incorrectly positioned as isotopes of the 3rd octave, which is impossible. So moving along, argon centers or anchors the 6th octave, potassium, calcium, and scandium come off. Then the 5 additional locking points open up. Keep in mind that our solar system is either manganese or iron. So one of those 2 isotopes fully explains the configuration of the Earth or the solar system, or maybe a better way to say it is the solar system clearly defines the specifications for one of these 2 isotopes. And it's just something that's important to remind ourselves of as we go through this. And then we see cobalt at 604 plus plus at wave amplitude. You can see now that these elements are becoming quite caustic to the human condition. Calcium is important, but cobalt isn't, arsenic isn't, selenium and bromide, you can find those as trace minerals, but if you encounter them in nature, they may very well be problematic. The isotopes are still something that are very valuable to us. And also keep in mind that these elements are getting bigger and bigger and bigger as they march through the periodic table, and they also travel faster and faster and faster. So by the time we hit tomium in the 9th octave, these will be throwing off bullets, radiational bullets, at the speed of light. So they continue to increase in size and they continue to increase in speed. Immediately after the 6th octave, the 7th octave echoes the 5 additional locking points directly after cobalt, then dissolves into the inert gas krypton, and then unfolds again into the second half of the 2nd octave at rubidium, strontium, I can't even pronounce this one, yttrium and rhodium. And again, an additional 5 locking points come off. Dr. Russell does not explain to us why there are 5 locking points in this and more in the next octave, but there are. So right now, we're just going to report the fact that this is what the periodic table states. So the 7th octave is the first octave that has isotopes at both ends of the octave at wave amplitude. The 8th octave, radiation is definitely in control now. And it has opened up 13 additional locking sites between the 3rd and 4th locking points. So in addition to the 7 elements, now you have 26 isotopes as well. So at this point, gravitation is holding on by its fingernails. These elements, I want to call them molecules, are getting bigger and bigger and bigger and faster and faster. And now we're starting to encounter unknown isotopes as well as unknown elements, where Dr. Russell has marked the position. So we know these locking positions must support isotopes and elements, but we have not isolated and identified them as of yet. So that shows you where we are in time here. Okay, so closing it up, let's talk about the ninth octave and what happens here. And I'd like to call your attention to a diagram that is found in Atomic Suicide, and you can see it as the top diagram here. We've achieved tomium at this point, and then Dr. Russell puts the sentence here in all caps. Matter ends here. Electricity can no longer compress. So here's the end of the periodic table at tomium. You can see it represented here as the last element in the periodic table. But we have learned, as with the case with all the dimensions, as in tone has no beginning and no ending. None of the dimensions do have a beginning and ending. The periodic table does not have a beginning and ending. And here's a little tidbit that Dr. Russell embedded in this diagram that I wanted to share with you in case you are unaware of this. What happens at tomium is radiation has won. Gravitation can no longer hold this molecule together or this element together. If you take one step further, no matter how small the measurement, off of tomium explodes. And that's what this diagram is showing us right here. Tomium explodes into what looks like billions of little parts. And these little parts are traveling along the octave wave. Remember, each one of them now must oblate. And what it does is it oblates into Alberton. And then it oblates further into Blackton. And it oblates further into Boston. And then it dissolves into the inertial plane, or to be more exact, into the inert gas alphanon, and the whole periodic table repeats itself. One interesting thing to note here is the ninth octave, as it's approaching tomium, is curving this way. But after tomium blows up, it curves this way. This is the only time in the periodic table where it does this. And after it does this, it will continue. It's curving its light wave format exactly so that it brings it back into the shape of tomium. So this is the only place that it flips the curve. And that's just something to notice. So with that, I'd like to open this up for discussion. And I thank you all very much for listening. Thank you.